Hi there, Jim Caffey here with OTC Online, and today in the astronomy course we're going to be doing Chapter 9 out of the Essential Cosmic Perspective book. This chapter is over asteroids, comets, and the dwarf planets, their nature, orbits, and impacts, the leftover stuff of the solar system formation. So we're going to talk about asteroids and meteorites first. Our goals for learning in this chapter are: what are asteroids like? Why is there an asteroid belt? And how are meteorites related to asteroids? And later on in this video, you'll have a chance to take part in the Thinkpairshare activity that I've discussed before. When this question pops up, you'll want to write down your answer and post it in the discussion board under this thread for Thinkpairshare. So let's get started. What are asteroids like? This asteroid, Ichigawa, was photographed by a Japanese mission, Hayabusa, which landed on a surface of the asteroid and attempted to capture a sample for return to Earth. How do we discover asteroids? Well, asteroids leave trails in long exposure images because of their orbital motion around the Sun, and because most of them do orbit between Mars and Jupiter, they do usually tend to move pretty fast in a 5-minute exposure, say, for instance. So here are some cool asteroid facts for you. Asteroids are rocky leftovers of planet formation. In fact, if you took all the asteroids together and lumped them into one big asteroid, it would not even be as big as the Moon. The largest of these is Ceres, with a diameter of about 1,000 kilometers or about 600 miles. Now, when the International Astronomical Union, or the IAU, demoted Pluto to dwarf planet, they actually upgraded Ceres to a dwarf planet, so it's no longer an asteroid technically. There are about 150,000 listed asteroids in catalogs, and probably over 1 million with diameters over 1 kilometer, or about 6/10 of a mile. Small asteroids are more common than large asteroids, and all the asteroids in the solar system wouldn't even add up to even a small terrestrial planet, like I said. So asteroids are generally cratered quite deeply and are not round. Their surfaces are very dusty, kind of like the Moon, where they have regolith, the dusty soil on the Moon. So the Dawn spacecraft, an American spacecraft, went around the asteroid Vesta. Vesta is elongated, has this weird band across the equator, and at the South Pole there's a impact gorge there that we can't understand right now. Some asteroids actually have moons. The asteroid Ida, for instance, has a tiny moon named Dactyl. So why is there an asteroid belt? During the formation of the planets, resonances formed in the solar system, and between Mars and Jupiter, according to Bode's law, which we have discussed in the class already, Bode's law says mathematically that there should be a resonance between Mars and Jupiter where there should have been a planet formed. But because of the gravitational contraction between Jupiter on one side and the Sun and the other planets on the other side, the planet didn't ever form together. Here is an asteroid, Metati, photographed by the Near-Earth Asteroid Rendezvous Mission, or NEAR. So here's the asteroid belt between Mars and Jupiter. Now, most of the asteroids do orbit between Mars and Jupiter, and the Trojan asteroids follow Jupiter's orbit. So we have a band of asteroids that are in another resonance around Jupiter called Trojans. And orbits of near-Earth asteroids do cross Earth's orbit, and these are the ones we have to watch out for that might impact the Earth. Right now, there are only a handful of astronomers around the world studying asteroids to look for ones that might impact the Earth, and they are all in the northern hemisphere. So if one comes from up the south, near the South Pole, we won't see it. And usually the ones that go by us, we don't find until after they whiz by us at a close distance. So we're very underfunded and understaffed in that endeavor. Okay, here is your Think, Pair, Share question. I'm not going to read it to you. Take a look. You have 30 seconds. Write down your answer, and then you'll post it in the discussion thread. Give you another 10 seconds. Okay, write down that answer. You'll post it in the discussion thread after you finish watching the video immediately. Here's your second Think, Pair, Share question. Again, 30 seconds. Give you 10 more seconds. Look at this. Okay, time's up. Put down your answer on your paper, put it in the discussion board by Friday night, and we'll reveal the answer on Saturday morning first thing. Thanks for watching.